Hi ladies and gentlemen, let's try to solve the question, the exercise 8.4. It says consider the hole diameter data in exercise 6.3. If specifications are at 0 plus minus 0.01, calculate CP and CPK. So we need to go back to exercise 6.3, which we didn't solve before. Here's the question in 6.3. We have a table. We have 5 values. The interesting part of this question is that it says the values reported are deviations from nominal in 10,000th of an inch. So when it says 10,000, we mean that 1 over 10,000. Let's write that part here. 1 over 10,000 means 0.0001. So the values here, for example, minus 30 is below 0.0001 and plus 50 is above 0.0001. So I just wrote these values in Excel here, and then I added all of them, minus and plus signs. The total was 40, and then I divide, because I had 5 values, I divided this number by 5, having 8. So this column is the average of all the lines. And then I took the maximum value of these 5 values, and then the minimum, and then find the range by subtracting minimum from maximum, because we know that range is maximum minus minimum. So when I found maximum here and then I found minimum, when I subtract this column from this column, I found the range. So here we have the average of averages. This value is here. Of course, this is 1/110th. So we go 4 decimal points to the left, which means that we have as an average 0.00109. And for range, again we go 4 decimal points to the left, which we would have as an average range. So this is average of the averages, which it has X bar bar, and here we have R bar, the range average is equal to 0.00635. So these are the values we will use for exercise 8.4. So let's go back to 8.4. What does it ask? It asks for CP and CPK. What's the equation for CP? It's upper specification limit minus lower specification limit all over 6 sigma. What were our specification limits? It is given in the question. It says upper specification limit is plus 0.01 and lower specification limit is minus 0.01. And here, because we have range as the value, let's write these values in our problem. So X bar bar was 0.00109, and R bar was 0.00635. So these were the values we found from exercise 6.3. And to convert the range value into a sigma value, we use this formula, which is sigma is equal to R average over D2. We take D2 value from table 6 at the very end of the book, our book. So this value D2 is for n equals 5. The value is, let's write that also, for n equals 5, because as you see here, we had 5 values, x1, x2, x3, x4, x5. So we had 5 values. N was 5. For n was 5, the D2 value is 2.326. And our ranges here, after we calculate this, our sigma is equal to 0.0027. So we use this value, this sigma value, in our calculations. Okay, let's go back to CP calculation. We subtract upper specification limit, lower specification limit from upper specification limit. So we write, as we wrote the values here, 0.01 minus 0.01, because our lower specification limit was minus 0.01. And at the bottom we have 6 sigma. So here we have, if we subtract minus from positive value, we end up with 0.02. So at the bottom we have 6 times. We calculated sigma as 0.0027, and we write it here. We will multiply it by 6, and as a result the CP value is 0.02 all over 0.016, which is equal to 1.25. So our CP value will be 1.25. Let's go on calculating the CPK value. In here, it's asked the CPK value. In order to find the CPK value, we have to first calculate the CP upper, and then calculate CP lower, and then take the minimum of these values. So the formula for CPU is upper specification limit minus x bar actually here, and all over 3 sigma. Let's put in the values in the equation. 0.01 minus the x bar value is here, 0.00109 all over 3 times our sigma, it was here, 0.0027. So if we calculate the CPU, we end up with 1.1. Let's try to calculate CPL lower, and that is x bar again minus lower specification limit all over 3 sigma. So that's the equation we use for the lower CP. And when you put the values in places, we end up with CPL equals 1.36. we take the minimum of this. Let's go on. So CPK is the minimum of CPU, CPL. Which one is minimum? Minimum of 1.1 or 1.36. We take CPK as 1.1 because that's minimum than smaller than this value. And these are the solution for this problem. What are they? CP is equal to 1.25 and CPK is equal to 1.1. As you see, these are not the ideal values. What were the ideal values? It was 2 for this and 2 for this. It is much smaller than 2 value, so it may not be at the center of the control diagram, and this is also lower than 2, which this process should be improved in order to have the ideal value, get closer to the ideal value.